from the I don't know, the cold day, the snow day, I forget which one. Last time we had class, I asked you guys to look at the first section or two from chapter 12 and to do, I think, 1 through 12. Right? That sound right? I'm going to redo all of chapter 12 here. So we'll start at the beginning and we'll do all of chapter 12 today. The majority of chapter 12 is either going to be conceptual or done entirely on your calculator. So if you have a calculator, I would have it out, because when we get to using it, you'll probably want to practice using the commands from your calculator. There's still a couple of extras on my desk if you want to borrow one. But that's the idea here. So in chapter 12, we start off by just defining what we mean by a polynomial, right? So a polynomial is like a type of function that can be written in this form. So a polynomial basically kind of looks like this. So each of these AI we call the coefficients. Those guys have to be real numbers. And then each of the exponents on our variable has to be a non-negative whole number. So those are like the two attributes for being a polynomial. It has to be able to be written in this form, where the coefficients on the variable are real numbers, and the exponents on the variable have to be non-negative whole numbers. So a little bit of vocab related. So each of these things that are being like added or subtracted, these are called the terms of the polynomial. So for example, this polynomial has n plus 1 terms. This specific coefficient on this term is called the leading coefficient. And similarly, this term here that has the biggest exponent is called the leading term. This guy here at the end is called the constant term. So just a little bit of vocab here. So when we talk about polynomials, typically we want to be able to classify them. And there's typically two descriptors we use to classify polynomials. So the first way is by the number of terms. So if our polynomial has just one term, we call that a monomial. If it has two terms, we call it a binomial. If we have three terms, it's a trinomial. Typically, we probably don't give a name for anything past three terms or bother with it because they don't commonly come up. And the second way to classify polynomials is by the degree. We'll talk about what degree is in a second. Man, you okay over there? Is that your stomach?
No, it's not my voice.
Was your butt?
No, it's not my voice.
So again, if we were classifying a polynomial by degree, again, we'll talk about how to find degree here in a second, or figure out the degree of a polynomial in a second. But if it's degree 0, we call that a constant polynomial. If it's degree 1, we call it linear. Degree 2, quadratic. Degree 3 is cubic. Degree 4 is quartic. And typically, after that, we just say, like, degree 5 polynomial, right? Like, nobody really goes past those names. Now, you guys talked about how to find the degree of a polynomial last year, right? In your Algebra 2 class. Does anybody remember how to find the degree of a polynomial or what the degree of the polynomial is? Yeah, so it is so we need to be a little bit careful or more careful than just saying highest exponent, right? Because we only care about the exponents on the variable. So the degree of the polynomial is going to be equal to the highest degree or highest exponent on a variable. Now, if there's more than one variable in the problem, like if it's got x and y in it, it would be the sum of the exponents. We'll do an example here in a second, but that's the idea. So for example, if we have this polynomial here, what degree is that polynomial? So we'd say degree 2. Yep. What's the degree on that polynomial? Nope. Nope. It's 4. If I look at the The term with the biggest degree is the x squared y squared, because it is got a degree of 4 on that term, because I have to add the variable or the exponent on the x and the exponent on the y, but only inside of a term, right? Does that make sense?
Mm-hmm.
So you look at them term by term and which one has the biggest.
So that sets it together, and there's like they could have had like 4 and 5, and it would have been 9.
Correct.
Okay.
Yeah.
There was like a plus between the x and y, but then the 3 then, right?
Correct. So what Alex asked is like, what if there was like a plus here? Now the degree would be 3. Yep, just 3. Even though you have 2 terms that are degree 3, it's still just 3. Right. But we didn't. Oops. Alright. Does everybody feel okay about degrees? Should remember this doing this last year, right? Just a little brief refresher. So let's do some examples here. I'm going to write some stuff down. We're going to decide if it's a polynomial or not. And if it is a polynomial, we'll answer some questions about the vocab related to polynomials. Sound good? All right. Okay. Is that a polynomial? Yes. Good. Why do you know it's a how do you know it's a polynomial?
So you didn't know x, x1, x2, or no?
So all the coefficients are real numbers. All the exponents are non-negative whole numbers, right? That's how you know, right? It fits the form. So what's the degree for this polynomial? 3, which means you'd say it's cubic. Yep. How many terms do we have? 4. Okay. What's the leading coefficient? -3. Yep. And what's the constant term? Everybody feel good about doing that kind of thing? Pretty easy, right? Vocab we should be pretty familiar with. What if we have that? Actually, let's do that. Let's do that. Okay. Is that thing a polynomial?
No.
Okay, why not?
The square root and fractions?
So not quite. The no is correct.
Oh, because that on the bottom of it,
On the
x, like the x3 is like the x3.
yes.
Can't have.
That is the issue, because what does that really mean?
3.
That's the same thing as 3x to the -3, right? Why is that a problem?
Because you have a
We
negative.
have a negative exponent. Correct. No negatives, no decimals, no fractions and exponents. Is there anything else the matter with it?
Oh, what is that square root 2?
That is square root 2.
No.
No, everything else is fine, right? Square root 2 is a real number. 10/7 is a real number. Those are both fine for coefficients. And since it's not a polynomial, there's no sense in talking about anything else, right? Is that guy a polynomial?
Yeah.
The answer is no. What's the matter with that? Yeah, so the x under the square root is the problem. So remember that because it's over both of them, that's the same thing as this, right? Which is the same thing as square root is the same as a fractional exponent. What's wrong with that? Not a whole number. So that's the reason why it's not a polynomial. Those are like the two most common tricks that you'd see as a problem. Mostly we try to obfuscate the exponents being, positive whole numbers or non-negative whole numbers is a way to trick you. Does everybody feel okay there? Okay. We're good about how to tell something's a polynomial and the vocab about the parts of a polynomial. Should be pretty easy, right? Again, purely conceptual, no calculation needed, not asking you to do anything. There's no adding or subtracting, no algebra going on, just like vocab, basically, right? The other half of this chapter is about modeling. So when we say modeling, we're not talking about like walking the catwalk, wearing fancy clothes. Nothing, no, it's a joke. What we're talking about is taking some data and constructing an equation that's going to kind of describe that data, to model that data, to give you something you can use to make a prediction about if I wanted to, if this happened, I'd expect this to be the output or whatever. Okay? So basically the idea with modeling is you're just going to take some data, you're going to turn it into an equation. Huh? Kind of. Is everybody okay with that idea? So the question then would be how do we judge the quality of our model? Well, one way that we'd have to evaluate whether our model is any good or not is how well does it fit the data. Okay, so fit is the first way we want to judge the quality of our model. So if that model is linear, we're going to use a correlation coefficient. That correlation coefficient is abbreviated with the letter R. So R is always going to be a number between -1 and +1. So at 0, we'd say that the model has no correlation, i.e. it's a terrible fit. At 1 or -1, we have perfect correlation. That means that the data or the model is an exact fit for the data. Meaning that that line goes through every single data point in our data set. Okay? If our R value is negative, means our linear model would have a negative slope to it. And if it's positive, then our linear model is going to have a positive slope to it. So again, the further you get away from 0 in either direction, the better your model fits the data. So things that are like in that point, like 0.9 range, it's pretty great. You typically aren't going to do much better than that from a realistic standpoint. Does everybody feel okay there? Okay. And we have yet to talk about how we're building these models or how we're calculating this R value or anything. We'll get to that. What do we do if the model isn't linear? Then we're going to use what's called a coefficient of determination. Goodness gracious, give me a minute. We abbreviate that as R squared. R squared always runs between 0 and 1, where 0 essentially it's no fit at all, it's terrible, it's the worst you're ever going to get. Means it's like literally that you could pick random points and they fit just as well as the points you have due to the model. And then 1 where it's a perfect fit, where whatever the equation for the model is passes through every single point in your data set. Is everybody okay there? So when do we use R? Linear. When do we use R squared? Everything else, right? Everybody feel okay? Again, we'll talk about how to calculate these things in a moment, but we're going to use the calculator to do all of this work. So I'm just going to load all the info about what it is that we're doing and how we're going to, like, what do we need to evaluate, and then we'll do some examples with the calculator and actually compute some of this stuff. But nothing in here we're going to do by hand. The other thing we need to evaluate is whether we're going to be doing interpolation versus extrapolation. So let's define what we mean by that. So to define interpolation and extrapolation, let's say that x min is the smallest x coordinate of any of the data points in our data set, and x max is the largest x coordinate of any point in our data set. So, and f of x is like our model that we have. If a is in between the smallest x and the biggest x, and we plug that a into f, what we're doing is we're making an interpolation. Okay? The prediction that we're making is an interpolation because it's inside the range of x values in our data set. If that value is smaller than the smallest x or bigger than the biggest x, and then we plug that into f and use it to make a prediction, that's extrapolation. Okay? So if you're doing extrapolation, typically unreliable. Even if the model's an excellent fit, unreliable. And typically when doing extrapolation, the further you get away from your x min or your x max, the more unreliable that prediction is going to be. This is why, like, predicting the future is inherently difficult, right? Like predicting the weather tomorrow, okay, do a decent job of that. Predicting the weather a month from now, no shot, right? You might as well roll dice. Same idea with like the stock market, predicting what might happen in the stock market tomorrow. Okay, maybe you got a shot at that. Predicting what's going to happen like a year from now, roll dice. Who knows, right? Is everybody okay? Interpolation, your prediction will be reliable assuming that your data's or your model's a good fit to the data. So you would have had to check, your R or R squared value, depending on the type of model you have. If that's a good fit, then if you're doing interpolation, you should get a reliable. But if you have a bad fit, even if you're doing interpolation, doesn't, what do you do? Crap in, crap out, right? Is that okay with everybody? Okay. So what I want to do next is I want to talk about how to select a model, right? Because we have these different choices, right? We have linear and everything else. How do I know what type of model to pick? So typically what you'd want to do is you'd want to build a scatter plot, which means basically I'm just graphing the data points. So if my data points look like this, probably want to use a linear model. Looks like a line, right? My data looks like this. I'm going to use a quadratic because what's that data look like? A parabola, right? My data looks like this. Where I have like two bends, it's probably going to be cubic. It looks like this. This shape of graph is called a hyperbola. This is indicative of exponential. And a graph like this is like we'd use like a power model for it. Okay? This feels like a test question, like a matching question on the test or something, where I give you some scatter plots and ask you to match it up with the most appropriate model. Everybody could see that. So if you're making a note card, maybe these pictures would be a good thing to put on there, just throwing that out there. So, what we're going to do now is we're going to look at some examples. So we're going to get some data. We're going to begin by creating a scatter plot from that data to look at the picture, choose an appropriate model, use our calculator to build the model, use our calculator to get either an R or R squared value so we can determine the fit, then use that model to make some prediction. See that? Does that feel okay? So at this point, I'm going to put an example data set on here and get the calculator on the screen. We're just going to be using the calculator to kind of follow along. Okay? See you, Julius. Insert. Yes.
Okay, I saw that. Okay, here. Hey, look at here. Oh my god, that's all.
All right. So to start, I'm going to show you how to enter the data into your calculator. So turn your calculator on. To enter data into our calculator, we're going to start by pressing the Stat button, which is right here next to the left-hand arrow. From the Stat menu, I want to be on the Edit tab and select the Edit command. Probably in there already in the previous class. Yeah. So what I've done is I've entered in my data here into L1 and L2. But I would have wanted to do something first. I forgot that this was already saved in here from the previous class. Before I started entering data, I would have wanted to ask myself one question. Right? I would have wanted to ask myself which variable should be the cause or the x, and which variable should be the effect or the y. So this data is about the price a store is charging per can of like a drink, and then the number of cans sold. So the cause should be the price, right? If I change the price, the effect should be I sell more or less of my product. So I want to make sure that my prices were my X coordinate. So I type those into my first list, L1. And the number of cans sold would be my effect. So I'll make that my Y coordinate. So I type that into the L2 space. Notice that when I tried typing in 2.50 and press enter, the calculator cut off the 0, because it doesn't really need to be there, just a placeholder 0. So don't worry about that. Luco?
Does it matter which one goes in the y-axis?
Yes.
Is it always going to be like the one that always goes on
No, so you want to think about like the situation, like which is the cause and which is the effect, right? So if you have a price and the number of things sold at that price, the change in price should be causing a change in the number of things sold, right? So the cause should be X and the effect should be Y. So in our case, the price should be the cause and the Y should be the numbers. Does that feel okay? Once I've typed these in, they'll stay in unless my calculator, I reset the memory or clear this data. So we've gotten the data into our calculator. So I'm going to exit out of here. What I want to do next is I want to build a scatter plot so I can look at the graph of this data. I don't want to do this by hand because, well, graphing by hand is time consuming and like neatness counts, and like I'm not about that. Like my calculator's way neater than I'll ever be. I want the calculator to do it for me. To graph data on my calculator, I have to start by entering it. We've done that already. And then I'm going to press the second button and the Y equals. That's going to open the stat plot menu. So there's 3 stat plots, so you can graph up to 3 scatter plots at the same time. I don't know why you'd want to do 3 at the same time, but you could. We're going to pick one of them to use. I'm just going to use plot 1. So I'm going to start by moving my cursor to the on position and selecting on. That first type option is the scatter plot option. That's the only one we'll use in this class, is that first type. Remember, I typed the X coordinate into L1 and the Y coordinate into L2. So where it says X list, I have the L1, and the Y list, I have L2. If for some reason you would type the X list into L3, perhaps, and you need to update this, notice on the numbers 1, 2, 3, 4, 5, 6 in blue are like L1, L2, L3, L4. So if I do second to activate the blue command and press the number 3, I could change that to L3 if I needed to. I didn't. Right, my X's were in L1, so I just want to leave it as L1. Is everybody okay? And then I personally like using the squares as my marker. I think they're the easiest to see, so I'm going to leave that option. Okay, before I graph this, I'm going to do 2 things now. First thing is I'm going to go into my Y equals menu, and I'm going to make sure that I'm not graphing any equations, because I don't want this all busy-bodied up with a bunch of lines or nonsense or whatever. These other 2 guys I have turned off. See, the equal signs aren't highlighted, so they're not going to graph anyway. After that, to graph this, the best way to graph a scatter plot is to press the zoom button and to pick zoom stacked. If you do that, your calculator is going to automatically change your window on your calculator so that it fits the data on the screen. You don't have to mess with your window bounds or anything like that. What does the error say? Okay. So I would guess that if you go to your Y equals, you have some gobbledygook in there that it can't graph. So clear all the junk out of there and try that one more time, and it should pop up for you. So this is our scatter plot. Everybody go okay with that? Okay. That's the graphing a scatter plot piece. I only need to do that if I don't know the type of model I want. If the question tells you to use, a quadratic model, do you need to do this? No. If it doesn't tell you the type of model that you need to use, should you do this? Yes. So just to be clear, everybody's good? Okay. On to the next thing. What I want to do next is I want to build a model to fit this data. What type of model should I select here? Looks linear to me as well. Let's do that. Everybody agree? Okay. So I'm going to press second in mode to exit back out to the main screen. And now, to build my linear model, I'm going to press the stat button once again, which is right next to the left-hand arrow. But this time, I'm going to go over to the Calc tab. And this is where all my modeling commands live. So if you look at commands 4 on, linreg, that's for linear regression. Regression is like a way to build the model. That's the process the calculator is using to build our model. I have quadreg, if it was quadratic, cubic reg, quartic reg, a different linreg. What's the only difference? Yeah, they're just the order they're writing the equation. Why is there this other one on here? I've never been able to figure out why anyone would use this one. I never have used it my entire life. I always just use the first one because when I write my linear equation, I always write it as mx plus b. I don't know anybody that likes to write it b plus mx. Maybe if you're really into biology. That's a BMX joke. Oh! And if you keep going down, I think there's a couple more. Yeah, so there's the exponential reg, the power reg. Everybody's okay? We're going to pick that first linreg command, though. So when I do that, it opens up a menu. It says, okay, where are your x variables at? Well, mine were in L1, so I'm going to make sure it says L1. Where are your y's at? Mine were in Y2, so I'm going to make sure it says Y2. Where it next says frequency list, that's always going to be blank for what we're doing in this class. You'll never ever have to fill that in. The fourth option says store reg EQ. So it's asking us, okay, I'm about to build this regression equation for you. Do you want me to do anything with it? And you should say yes. We do want to store that someplace because we're going to want to use that to make predictions later on. Or even maybe want to graph that against our scatter plot to visualize how good the fit is, right? Those are all things you might want to do with your scatter plot or with your model. So where do we want to save this? We want to save it into one of those y equals spots on our calculator. So I'm going to have the calculator put my regression equation into y1. So that's the symbol that I want to put there. To get the y1 to go in that spot, to retrieve the y1, I'm going to press the vars button, which is right underneath the down arrow. That's short for variables. Now, if I want the y1, y's are y variables. So I'm going to go over to the vars tab. And our calculator in this class is always in function mode. So I'll always pick function, and there's the y1. And now I'm just going to press calculate, and the calculator has told me, here's your model. Your model is y equals ax plus b, where a is negative 104.68 yada yada yada, b is 329.28 yada yada yada. So your equation, if you're going to write it down on paper, you'd say like y equals negative 104.7x plus 329.3.
Mine doesn't show the R.
Great, we'll get to that. We'll get to that in a second. Yep. Is everybody okay? All right. So notice that mine has output the R values, right? The R squared and the R. And at least James and Alex says, my calculator didn't do that. So if your calculator is not doing that, you need to do the following just one time, unless you reset your calculator's memory or something. Once we do this, your calculator will save this setting so that next time you do it, a regression, the R's will come up for you. So if your R's didn't come up, your R's came up, you can ignore this step, unless your calculator memory gets reset or something. You want to press second and the number 0. This opens up the catalog. The catalog is just a list of every command on your calculator in alphabetical order. The command we're looking for to get those R's to show up is called diagnostic on. So we could scroll all the way down to the D's, or if you look at, there's like these little green letters, A, B, C, D, etc. on the buttons. If I press the one with the green D, it skips me all the way down to the D's. That saves me a whole lot of button pushing. And I'm just going to scroll down till I see diagnostic on. Once I've found that command, I'm going to press enter to put it on the home screen and press enter again. Now it says done. So if I go back and I do stat, calc, linreg, store it to Y1, and press enter. Now your R's should show up. Okay. Let's note what else has happened, though, after we did this. Because we chose to store that regression equation. If I press the Y equals button, what do you see there in Y1? That's the equation the calculator just made for me, right?
Yeah.
So that means that if I hit graph, there's my model relative to my scatter plot. That's pretty nice, right? So we have some data, right? What if I want to use this data then and say, like, I want to predict how many cans I'd sell if I charged $5, right? So to do that, what am I going to do? I'm just going to be plugging 5 into the X in my model. Right? Now, I could do that by hand, but did you see how many decimal points I had for my A and B? There's a lot of typing. I'm not about that life. If you know how to ask your calculator, the calculator will go ahead and just plug 5 into the equation in Y1 and spit out the answer. I like doing that a lot better. So let's do that. Okay? So I'm going to exit out of here back to the home screen, so just second in mode. And I can use those equations into Y equals menus, just like a function equation, or function notation, I should say. So I'm going to go ahead and retrieve that Y1 command again. Where was the Y1 variable located? Vars, and then Y vars, and then function, and there it is. And then I can just do like Y1 of 5, like I would do like F of 5. And what it's telling the calculator, it says just plug 5 into that equation. So it predicts I would sell negative 194 cans if I charge $5. Does this answer make sense?
No.
No. Okay. Why is this prediction unreliable?
Because it's negative. It's a negative amount.
I love Luco's answer the best. What did you say for everybody? I'm doing extrapolation, right? This input, this 5, is outside of the range of data. Should I trust this prediction? No. Even if it gave me a positive answer. Not reliable. Okay? Now, if I wanted to do the same thing and say, okay, how many would I sell if I charged, $1.25 or $2.20 or $1.90, right? So rather than jumping back through all those menus again, I'm just going to go up and grab it and then just type over. So I predict I'd sell 130 cans if I charge $1 now. Which should make sense, right? Like, I should sell more than I did at 108. You notice that it's predicting more than I would sell at $1.75 also. That's okay. Right? Because if I look at my model, this is where 175 is. I'm like underperforming what the model would predict. I'm not selling as many as the model would predict me to, which is fine. That can happen.
When I put in $1.25, it gave me.
We did $1.09.
Okay, no, I was just saying for the, okay.
Yes, and if you plugged in $1.25, then you're probably going to get a number less than 207.
Got it.
Right? Because look at where 207 is and where the model is.
Okay.
Is that okay? And that's okay, right? It's just a prediction. It's not.
That's just what I was a little
Actual.
confused about was.
Yes. Yeah, they will be different. Which one will the prediction be the closest to the actual? 150, right? That's this point right here. That's basically on the point is on the line, right? Does everybody feel okay about like what we're seeing visually? What if I ask you the reverse question? What if I said, well, I have 150 cans in stock. What price what's the most I can charge to try to sell all of them? So what you'd want to do is you want to find where 150 intersects our model, right? So I'm going to go to my y equals, I'm going to save these things because I want them in for another class. I'm going to just type in 150 as a y, and I'm going to hit graph. And I'm going to find that intersection. So on my calculator, to find that intersection, I can press second and calc. Which command here looks like the one I want? Intersect, of course. And then because I just have two curves here, and they're both straight lines, they can only intersect how many times? Once. So I'm just going to press enter 3 times, and it says I should charge about $1.71 to sell 150 units. How's that feel? So this is basically what the test questions will look like. Conceptual stuff, and then just stuff where we use our calculator to answer questions. I'm gonna give you guys another example, let you guys work on it, and then we'll buzz through it real quick and last like 10 minutes of class. Sound good? Okay, so I'm gonna give you some new data. Let's grab that one.
Have a good day.
You're welcome. So pull out your calculator. Try to look at the scatter plot, pick a model, build the model, and then let's find like and then solve for when f of x is, say, like 2,000. Oh my goodness, guys. Is it ever gonna warm up again? I've been.
I got sometimes when they were like, guys, make sure you're parking correctly, and like, you can't see the spots. Yeah.
And the point of like, don't park in the teacher spots, okay, great, we can see the difference between yellow and white lines, and we have enough space to entirely avoid the section where the teacher spot is. When the parking lot is full in the morning,
Also,
I don't even drive and I can see the problem there.
just do your best. And also when they were like
Not for the best to see enough for her.
Well, some people are parking like right in the front.
Okay, that's fine.
Like,
Well,
like
it's-
it's. I don't think anybody's gonna
They
be
do that
upset if
anyway.
you're like, you know, oh, I was one spot in from where I was supposed to. Like, okay, like I think everybody cut you some slack there. But if you're like, yeah, I parked in the very, very front, it's like you weren't supposed to park there. But you
what
couldn't see
doesn't
it,
make
you know
sense
the
to me
difference.
is that Amelia asked for parking in the senior spots, because if we could see that, like, we can't see where the senior spots are. It's not like we have.
They're all in the same row.
They're all in the same row, but it's
Yeah,
still.
just don't park in that room. Done, easy.
I don't think we
After
have like any room.
I park. Yeah, I park.
After we get the data, like on our calculator, what's the next
So
one?
far away.
Yeah.
Why don't you have to wait to look at the scatter plots?
Oh yeah, how do you get there?
No, I park E, but I park by like the second post. Like I park like halfway between the first and second.
Yeah, first and second.
I now have a
Oh, it's-
deadline
it's edit.
for when I need to start.
Leslie, when are you taking?
How do I like
I'm
sort?
going to have my license.
Did you enter the data into your
That's
calculator?
when my
No,
younger
'cause
neighbor.
I
will
don't
get
know
her license,
where
and I
I
cannot have that.
Stat.
I got my license recording today.
Edit.
It failed the test, so it's not a huge accomplishment.
I passed first time. So it was on the test.
I just have to take it.
It was during the test. So I realized
That's kind of stereotypes.
it's just kind of
I talk about this morality. Also, Mr. Seltzer is on board for getting a period cramp simulator and the morality curriculum.
Okay, what did you say?
A period
No, I wanna
cramp
see it.
simulator.
No, but before that, Mr.
He's
Sisters.
on board with it.
How do you know?
I'm trying to see if
Because
it's
I
money
talked to him,
or.
and he's like, I'll figure out all the paperwork, you just gotta get with it.
Boy, I don't know.
That's fun.
So I wrote on the board, those are the two end
I
questions.
don't think,
because I did write it down.
see how, I can give you an next year, I don't.
I've gotten all of them, I've gotten both the Spencer and
Yeah,
Mr.
just Spencer
Seltzer
also.
on my side,
Spencer
plus
also.
Mr. Price.
Yeah, no, I know, but that's also.
We're able to watch a birth video.
Yeah, I think I got it.
No,
Which is why there's consent forms that are gonna happen.
you know. Yeah, I don't.
My husband is really weird during it.
What? What'd you say?
I mean, if you have a type of couple to volunteer, I feel like you gotta keep it off.
No.
But
Oh. Yeah, no,
this is like a.
it was like 9 months. Yeah, it was like 9 months in the beginning. Like, they've been planning it.
Yeah.
They hadn't decided who was gonna carry the baby. They had time to. They probably just like asked. They probably were like, give one.
Oh, and then.
The way you said they chose this couple to have.
So that's your scatter.
I got the equation, I'm just trying to figure out how to plug into 200.
Well, what did you, what equation did you pick?
What?
What equation did you
Really?
pick?
Is that not letting me?
I'd pick exponential. That to me more looks like it's like less straight than it is curving and coming up.
Also, that's not,
Oh, and then you go, yeah. Okay, yeah, I got you. I got you.
this is exponential.
Did she say anything when you?
Yeah, because okay, I got the A, B, R2, and R.
Wow.
I'm just confused how to plug into 200 now.
I'm so confused.
Yeah, I got that.
So if you look at your graph, there's that.
What was your But I don't know what's probably one. So then you go to the bars.
You're supposed to be trying to focus.
Oh, there we go.
Your mom? Yeah, she goes, oh, shit, I can call it. Wow.
Why is my phone at the
Okay,
here?
so it's a 65.
Just connect this. Mr. Cool, how did you get into the show the equations in the one
How did I what?
How did you get it to show you the equation and like into the line?
All of her contacts.
Did you store the regression, store reg EQ as y1?
Yeah.
So you press y equals, there's an equation y1. It's the same exponential equation that you generated. Did that happen or no?
Like everyone else.
Well, I have it as
Yes.
Like I have it as this. I get those numbers. I'm so. How do you store it?
It says store reg EQ on that previous menu. Use the touch.
They also offer exchange.
It tells your calculator to save this equation.
One of my years of college.
Fast, don't crash. Don't pull a Massimo, you know?
Oh, there you go. Got it.
Yeah, but how do you look in there?
I actually go.
Yeah.
There you go. Dutch. I know.
This never.
I said another
Stored the answer.
That's what I said.
It's not stored. Going to the next
If you were thinking about saying Netherlands.
Yeah.
It's just some random.
My sister's my mom right there. I don't want
The T90.
Bro, I have the TI-83, bro.
I know she lives there. She lives on like I don't know if she does upstairs. I don't know much about my
It's
house.
another small difference, but I think you're fine.
I don't know much about my house. My mom says, oh yeah, by the way, most of your, you have about 6 months that are doctors. And everybody in your dad's business. So I feel like we need to do that.
Okay.
Well, it's an Arabic. Well, I'm in Arabic.
You got this
Uncle is on the.
figured yet?
Which is really
I
similar
have it,
to
and then
my mother
I
is
don't
Oma.
know.
So it's Oma and
Or
Oma.
what, man?
My Wyman.
Two things that
And then what do I do after that?
Well, I don't know that this is going to be US, like US.
Oh, shoot.
No, bro.
I have this.
This is not what do
We're
I
gonna drive more.
to not
There
do?
to, there to,
When I have to go in.
Yeah.
I just kind of want to
Also, they're the only
bars.
I didn't plug all this to kind of know what
What did I do?
Dutch tracks.
Oh, the fact that they cannibalized a guy?
Yes. Yeah.
Very long story.
They civilly candlelight the guy, not just candlelight.
They were very polite,
Yeah.
apparently, according to a bunch of different sources.
Oh, there we go.
So again, this
What do you do very confident? You should do that here.
this test, the homework quiz, is going to be all about your calculator literacy. Like, can you use your calculator? So you gotta figure this out. My suggestion for you is when you go home and work on the homework, which you should do immediately. If you don't remember the calculator steps, what can you do? pull up the video, right, where I walk through the buttons and do everything on the video and follow along again until you kind of remember where the menus are for these things. Because just to let you know, we've now finished chapter 2. We've done everything. Should expect homework quiz imminently and a test probably next week, early next week. Like, I don't have anything else to really do. This is the easiest test of the semester. All you have to do is be able to use your calculator.
Oh no, I'm getting 99 still.
I know, Mark. You're gonna forget to round something or.
Yeah, 4 on the right, 4 on the actually 4 on the one.
We're with the scientific meditation test.
So you know to be on the mainstream first.
You know, I know.
Now you.
I found out how to cheat.
So I
have to be able to do that.
Oh yeah, no, see, I just figured out with the calculator. I don't think I either he didn't realize or just thought.
So again, make sure you spend some time doing the homework, knowing how to use the calculator.
I'm locked in on this one, bro.
Yeah. So I know.
Bro, I'm telling you, man, this one's it, bro.